This is TMUA 2021, Paper 2, Question 12. We're told f and g are polynomials, and we want to determine which of these statements is true. So let's look at the first statement, which first says that if f is bigger than g for all x positive, then the integral of f from 0 to x is bigger than or equal to the integral of g over the same region. Does this statement seem true? Well, this first half of the statement is saying if f of x is bigger than g of x, that's the same thing as saying the curve of f is above the curve of g. And this statement is saying the area under the graph of f from 0 to x is bigger than the area under the graph of g. So, on first glance, it seems true, or seems plausible. So maybe let's try and prove this. So, maybe to try and prove this rigorously, we may want to move everything onto one side. So, saying f of x minus g of x is bigger than or equal to 0. Why do we do this? Well, we do this because we want to compare our function to some fixed value. In this case, it's 0. And that's easy to work with than comparing f to g, when both of these things could be some two arbitrary polynomials. So we want to show, moving this g to the other side, that the integral of f from 0 to x minus the integral of g from 0 to x is positive. What can we do here? Well, we note that these two integrals are over the same interval, 0 to x, so we can move these together into one integral. So it's the same thing as saying the integral of f minus g from 0 to x. And what do we know about this? Well, by our hypothesis, we assume this thing is going to be bigger than or equal to 0. Therefore, we're integrating something that's positive. So, what does that mean? Well, precisely because the integral is area under the graph, if this thing is positive, our integral will be non-negative or greater than or equal to 0. So, we have proved our desired inequality. So, statement 1 is true. What about statement 2? This is saying if f of x is bigger than g of x, i.e. the curve of f is above the curve of g, for all x positive, then the first derivative of f is bigger than the first derivative of g. This seems false, because this is a statement about the location of f and g, and this is a statement about their gradients, and these seem unrelated. So it seems false. So can we find a counterexample? Well, to show a valid counterexample for this, all we need is an example of f and g where this thing holds, but we need this thing to fail for only one value of x positive, because our statement says this should be true for all x, so you only need to show it fails for 1 point. So what example can we take? Well, let's just set g of x first, and let's just take an easy case. So let's say g of x is equal to x. So drawing down a graph, it looks something like this, and we know that g prime of x is equal to 1 for all x. So what kind of f can we take? So we want an f that's going to be above g of x for all x, so it's going to be in this region, and we want it to have a derivative less than 1 at some point in this right-hand side of the plane. So we can just easily just take a parabola which has a minimum at some point, and that would have derivative 0. And then if you just translate it high enough, we can make it so that it's always above our blue curve. So one example you could just say is f of x is equal to x minus 2 all squared plus 10. So statement 2 is false. What about statement 3? This is saying the converse, and we just said that the statement about position and derivative seem unrelated. So by the same logic, it might suggest that this thing is false. But why is that? Well, it's because when you translate something, the derivative doesn't change. So if I move this line y equals x up by 1, it still has derivative 1. It still has gradient of 1. So what would a valid counterexample be? Well, we could just say, take f of x is equal to g of x minus 1. So f of x is the derivative of f is going to be equal to the derivative of g for all x. But f of x is just going to be g of x translated below by 1. So f of x is going to be strictly less than g of x for all x. So this is a valid counterexample. So statement 3 is false, which means that the answer is B.